In this video, we're going to look at operations with functions, and that includes f plus g of x, f minus g of x, f times g of x, and f over g of x. We're also going to look at compositions of functions, f in composition with g of x, and how to find this result. In addition, we will do an introduction to inverse functions. Let's look at the operations with functions. F plus g of x means you add the formulas for f of x and g of x. F minus g of x means you subtract the formulas. F times g of x means multiply the formulas. And f over g of x means you divide the formulas. And this seems easy enough, and it is very easy. We'll take a look at some examples with these operations. Here we have an example where f of x is defined as 2x plus 5 and g of x is x squared. And we're going to find f plus g of x, f minus g of x, f g of x, and f over g of x. F plus g of x means you simply add the formulas. So you add f of x formula 2x plus 5 to the g of x formula x squared, and you get the result x squared plus 2x plus 5. To find f minus g of x, we subtract the formulas. The f of x formula of 2x plus 5 minus the g of x formula of x squared, and we can simplify that as negative x squared plus 2x plus 5. F times g of x is, as you would expect, the multiplication of the formulas. We take 2x plus 5, the formula for f of x, times x squared, the formula for g of x, and multiply them together. And this simplifies as 2x cubed plus 5x squared. And then finally for f over g of x, we divide the formulas and we get the f of x formula divided by the g of x formula, which is 2x plus 5 over x squared, and that is defined as long as the denominator x squared is not equal to 0. Now let's look at a few more variations of these operations. We're going to find f plus g of 10, g minus f of 2, f g of 5, and f over g of 0. F plus g of 10 is going to equal f of 10 plus g of 10. So we plug 10 into each of the formulas and add the results. And this gives us 2 times 10 plus 5 plus 10 squared, which simplifies to 125. Now for g minus f of 2, the g of x function is first. We get g of 2 minus f of 2. G of 2 is 2 squared. F of 2 is 2 times 2 plus 5. We subtract the results, get 4 minus 9 equals negative 5. For fg of 5, we're taking the product of functions evaluated at 5. So we're taking f of 5 times g of 5. F of 5 is 2 times 5 plus 5, which is 15. G of 5 is 5 squared, which is 25. 15 times 25 makes 375. And then last, we have f over g of 0. That's going to be f of 0 divided by g of 0. F of 0 is 2 times 0 plus 5. G of 0 is 0 squared. So we just get 5 divided by 0, and division by 0 is undefined. So our last answer here is just undefined. Now let's look at the definition of composition of functions. And the composition symbol is this small o, or so it looks to be a small o, so it almost looks like the word fog of x, but it's not an o, it's an operator. F in composition with g of x means we replace each x in the formula of f of x with the entire formula of g of x. And I'll show you this with some examples. Here we have the example, f of x equals x squared minus x, and g of x equal x minus 4. We're going to find f in composition with g of x, g in composition with f of x, f in composition with g of 3, and f in composition with f of x. We'll start with f in composition with g of x. For f in composition with g of x, we plug the formula of g of x, which is x minus 4, in for each x of the f of x formula. So we're really finding f of x minus 4. So we have two x's in the f of x formula. We have x squared minus x. So when we do the composition, we get x minus 4 quantity squared minus another x minus 4. And you could simplify this more, but I'm just going to leave this result as is. Now let's look at g in composition with f of x. In this problem, we take the formula for f of x, which is x squared minus x, and plug it in for each x of the g of x formula. Well, there's only one x. When we take g of x squared minus x, we just plug in that expression, x squared minus x, in for x of the g of x formula, and we get, instead of x minus 4, x squared minus x minus 4. When we're taking f in composition with g of 3, what we're really doing is taking f of g of 3. Instead of an x, it's a 3. So what you do here is you plug 3 into the g of x formula. G of 3 is 3 minus 4, which is what I have right here. So 3 minus 4 is negative 1, and that's what we plug into f of x. F of negative 1 is to take negative 1, square it, and then subtract it, because that's what the formula for f of x says to do, square and subtract. So we get 1 minus a negative 1, that simplifies to 2. Now, in our last example, f in composition with itself, what we're doing is we're plugging that function f of x, we're plugging that formula for f of x, x squared minus x, in for each x of f of x. So we take the formula, square it, and then subtract it, because that's what the f of x function says to do. Square the input value, then subtract the input value, and I'll just leave it in this form. In our next problem, we're to find two functions f of x and g of x such that the composition of f with g of x ends up giving us 3x minus 1 quantity squared. Now, it turns out there's more than one answer here. In fact, there's an infinite number of answers, and you'll see why. But the most obvious answer here, I think, is to have a squaring function that takes an input of 3x minus 1 and squares it. Well, that means f of x would be the squaring function, so f of x equals x squared, and g of x would be the input plugged into the squaring function. So then when we take the composition of f with g of x, we're plugging the 3x minus 1 into the f of x function, squaring it, and getting our 3x minus 1 quantity squared. Now there's a lot of other answers. We could have f of x be x minus 1 quantity squared, and then g of x be 3x. When we plug in 3x for x, we get the end result of 3x minus 1 quantity squared. We could also have f of x be x minus 2 quantity squared, and g of x be 3x plus 1. So that when we plug in 3x plus 1, the 1 minus 2 turns into a negative 1, and we get 3x minus 1 quantity squared. We could just bump g of x up to 3x plus 2 and make f of x x minus 3 quantity squared. And as you could see, we could just keep going with this forever. 3x plus 4, x minus 5 quantity squared, etc. So there's an infinite number of possibilities. Now, continuing with this idea, whenever we have f of x and g of x such that the composition of f with g of x equals x, and also g in composition with f of x equals x, we say that f of x and g of x are inverse functions of each other. That is the definition of the inverse function, and I have an example of this. Here I have f of x equals 3x, and g of x equals x over 3. When we do the composition of f with g of x, we're plugging that x over 3 into the f of x function, and we're getting f of x over 3, which means we're tripling it. When we take 3 times x over 3, it simplifies to x. Now the composition the other way gives us g in composition with f of x, which means we're taking g of the f of x function. The g of x function is to divide by 3, so we take 3x divided by 3, we end up with x. And the thing to remember about inverse functions is they reverse the operations of each other. F of x triples g of x divides by 3. When we plug something into f of x, we triple it, but if we take that result and plug it into g of x, we divide by 3, and we get back our original input value.